All right, let's do this. First thing, just let me remind you, because this kind of goes into what I'm about to do. A squared minus b squared. Can you factor that?
Oh, wait, yeah, factor. I thought you meant subtract.
Can you factor that? A squared minus b squared. What's the method called? Difference of two perfect squares, right? And you guys know when you do difference of two perfect squares, what do you know about the signs in the parentheses? Always opposite, right? And how do I figure out what goes in what spots? You basically take the square root of what's there. Square root of a squared. So that the square root of whatever's there goes in the first two spots, and then you take the square root of the second term, b and b. Everyone, we're all in agreement there? So if I give you 25y squared minus 4x squared, we see that's difference of two perfect squares, right? So we say, all right, I know the rule says signs are opposite. What's the square root of 25y squared? 20 or 5y, so that goes here and here, 5y, 5y. And what's the square root of 4x squared? 2x and 2x, all right, 2x. We're going to do the same thing today, but now with cubes. Okay, perfect cubes. And the difference is, difference of two perfect squares, if I change any of these to a plus sign, does it work? No. Well, cubes, you can factor sum and difference. So you're going to see adding and subtracting. All right. Before I even sniff any factoring problem that involves cubes, let's talk about what a perfect cube is. Take out your calculators if you don't have them out already, because I think you guys will remember this more if you actually do this on your own instead of me telling you. Yep. All right, guys, so here we go. Let's talk about numbers that are, because you guys know numbers that are perfect squares, right? 4, 16, 9, 25. We went through there. So let's talk about numbers that are perfect cubes. Right off the bat, 1 is a perfect cube. Okay, 1. In your calculator, 2 cubed. Go ahead, 2 to the third. And that brings your next perfect cube, which is 8. Yep, 8 is a perfect cube because it's 2 times 2 times 2. How about 3 times itself 3 times? 27. What you guys are doing are finding perfect cubes. So go ahead, 4 times itself, 3 times, 4 to the third, 64. So all of these are perfect cubes. We'll go up 2 more. 5 cubed, 125 is a perfect cube. And then 6 to the third, 216. And we could keep going. There's infinite perfect cubes. But just so you guys know what a perfect cube is, take a number in your calculator, multiply it by itself 3 times, and that'll be a perfect cube. All good. All right, what about variables then? I think we discussed this. How do you know when a variable is a perfect square? Like, is x to the 102 a perfect square?
Yes.
Yeah. As long as it's x to the 68 is a perfect square. As long as the exponent is even, it's a perfect square. Okay? Well, what makes it a perfect cube? Here you go. X to the third, y to the 6th, a to the 12th, b to the 27th. Anybody want to tell me what makes a variable a perfect cube? If the exponent is correct, divisible by 3. All right, if your exponent is divisible by 3, it is a perfect cube. All right, you think we're ready to tackle this? I'm just going to get yourself mentally prepared. 1 is going to be a little bit rough just because it's the first one. Okay, and then when we go from there, we'll pick it up. All right, so when we did difference of 2 perfect squares, we noticed, all right, it's the signs are opposite, and I just put the square root of A and the square root of B in those positions. Well, when I do perfect cubes, there's also a pattern. It's just a little bit more lengthy than difference of squares. So let's talk about the sum of 2 cubes. A cubed plus B cubed. All right, I can factor that. I know I can't factor it with perfect squares, right? Because it's got to be subtraction. But with cubes, I can do it. When I add two perfect cubes together, I can factor it. And here's what it factors into. And it looks like a mess, but it's fine. It'll be all right. It factors into a plus b. And then in the second parentheses, a trinomial that says a squared minus ab plus b squared. Okay? And I know, how am I going to remember that? You're going to do it enough. It'll just be commonplace for you. Here's a couple things. Whatever this sign is here always matches the sign in the first parenthesis. And then it's the opposite sign in the middle of the second parenthesis. Okay, that's how I remember some of these things. All right, so again, when I factor the sum of two cubes, it's a plus b, and then a squared minus, that changes signs, plus b squared. It's nice to talk about it. How about we actually do one? All right, how about we do one? This is not in your notes, but I appreciate it if you wrote it down under sum of two cubes. There's just not many examples I have for you today, so I wanted to add in a couple where I could. First of all, I got a problem. We went over all these different examples of cubes, and the only cube I see up there is 8. X to the fourth is certainly not a perfect cube, and neither is x. So why am I putting this under perfect cubes? I yell, I scream about it every day. What are we doing first? GCF. Look for it first. If there's a GCF, darn it, take it out. What is the GCF? X. Here we go. When I take an X out, what's left? 8. Oh, 8x to the... Oh, to the third. There's a perfect cube plus 1, which is also a perfect cube. There we go. Now does everyone see the perfect cube? And we're adding. Here we go. You ready, Maeve?
I'm so ready.
I'm sure you are. All right, so what I like to do is I actually like to write the whole a plus b, a squared minus ab in my problem here. So a plus b, a squared minus ab plus b squared. And I am going to substitute in for a and b in a second with your help. But what did he just do? He just went from x's to a's. I'm just writing out what the perfect cube is equal to from the top of your page right now. Okay, now here's the math involved. I need to know what to plug in for a, b, a squared, and b squared. All right? So what I'd like you to do first, look at what I have inside the parenthesis right now. What is in the a cubed spot right now? What is in the a cubed spot in my parenthesis? A cubed, what's in its spot right now? 8x to the third. Everyone agrees? 8x to the third, that's what's in there right now. Now use your math ability. If a cubed is 8x to the third, what's a going to be then?
8.
Well, not 8 anymore. I'm going to take the cube root of everything. So 8 becomes what when I take the cube root? 2. And x cubed becomes x. So everywhere I see an a, I'm going to plug in 2x. All right? Let me do it for b now. What's in place of b cubed inside that parenthesis? A 1. So what's your b value then? If b cubed is 1, what's your b value? 1. Cube root of 1 is 1. You ready to substitute with me now? All this is, I like to call it plug and chug. Plug in and chug away. Ready? What was the a value we just found? 2x. Plug it in. 2x plus, what was the b value? 1. All right, so look, you got your first part of the factoring done. It's 2x plus 1. Now do a little math for me. A squared. What was the a value? What was the a value? 2x. So I'm asking you to take 2x and square it. We've done this. This was day 1, exponents. What is 2x all squared? 4x squared. Everyone all right? Minus, what's the next part say? A times B. Minus A times B. 2x times 1, which is 2x, plus B squared. 1. Congratulations, you just factored your first perfect cubes. All right, and I can guarantee you that I will not do this to you, that there's more to go. All right, that you have to keep, let's do a little trial, guess and check on this. I won't do that to you. This is tough enough. Identify your A cube value, then find what A is. Identify your B cube value, find what B is. Questions? Again, the first one's always the toughest because it's the most awkward and most uncomfortable. And yes, I did have to take out a GCF first. Questions? All right, so that's the sum of two cubes. You can also do difference of two cubes. And look what that's equal to. Oh, just like for the sum, it matches the sign matches the first parenthesis. And look, what's the middle sign in the second parenthesis? Opposite. Okay, just like the last one was. It's always opposite in the second parenthesis. All right, so please copy down this 64x to the third minus 27y to the third. This is the difference of two cubes. Any GCF? Any GCF? Nope. Okay, here we go. It's up to you what you want to do first. I'll write out what it's equal to. So A minus B, signs always match, times A squared, opposite sign, plus AB plus B squared. All right, you guys ready? Help me. What is the A cube value here? What's in place of A cubed? Here we go, numbers time. Everyone wake up at home. What is the A cubed value here? Whew. Only another day, actually a lot more days. Sabrina, what's your A cubed value?
64.
Good, 64x cubed. Knowing that now, somebody tell me what's my A value then? What's my A value? 64 is a cube and so is x cubed. So what's my A value then? 23. Luke, what's my A value?
4x.
Good, 4x. Remember, we're doing cubes, not square roots. So if somebody told me 8, you're doing square roots. These are cubes now. 4x. Good job, Luke. All right, let's go B cubed. What's my B cubed value here? 20. Radhika, what's your B cubed value?
B cubed is 27y.
27y to the third?
Would it not be negative?
Nope, because the minus is already there. Okay, this is what's nice about it. You don't have to worry about the signs. You could just, the A is what comes first and the B is what comes second. All right, and what's my B value then? If 27y to the third is B cubed, B would equal 16. Kyla, what do you have?
For the last one?
No, just the B value.
Oh, okay. 3y.
3y. There you go, guys. Good job. Ready to plug in? Okay, so A minus B. 4x minus 3y. And this will factor into, all right, again, this is where the little slight mathematics comes in. A squared. 4x all squared. Not 4x squared. Hey, I'm not looking for this. I'm not looking for, that's not what I have here. 4x all squared. So this is what I'm looking at. 4x all squared. What do you have for me? Back to, hi, Zach. Back to nobody. 4x all squared.
8x squared.
Oh, I'm going to slam you. 4 squared, not 8.
Oh, sorry.
You should be.
16.
16x squared, thank you. 8. A times B. 3x times 4x times 3y. What do you have? AB. 2. Quincy, what do you have? A times B.
It would be negative 12x.
Not negative. Why negative?
Positive.
Just 12xy. And then b squared. 3y all squared. What do I have at the end here? 3y all squared. Luke, going back to you. 3y all squared.
9y squared.
Good. There it is. Don't have to worry about factoring further. We're good. You guys are going hardcore now, huh? This is real Algebra 2 deal here. Questions? Okay, and then I gave you, I'm not going to do this one with you because the work's already there, but take out a GCF, difference of 2 cubes again, down at the bottom. Okay? All right, so on the next page, you guys have 5 examples. I'm going to do 2, and then you have the other 3 for homework, and that's it. Okay, that's it. That is, and by the way, your last assignment of the year tonight. I know I really laid it on thick, huh? 3 problems. Now we're going to do number 2. Let's hop over to number 2. I know some of you may not like the exponent there, 3n. Stop. How do I know x to the 3n is a perfect cube?
It's a multiple of 3.
What did we talk about? If a variable is going to be a perfect cube, what do I know about its exponent? Divisible by 3. Is 3n divisible by 3? Then it's a perfect cube. All right, then it's a perfect cube. And 27, we should know, we wrote that down. So both of those are perfect cubes. They're addition. Ready? If it's addition, a plus b, a squared sign changes to minus ab plus b squared. All right, there's the rule. All right, now we got a little work to do. A cubed. What's in place of a cubed here? Ooh, oh. The suspense is killing me. All for that. Vinny, what's the a cubed value here? What's in place of it?
X to 3 times n.
Yep, x to the 3n. Now, everyone be careful now. What would your a value be then? What times itself? 3 times is going to give me x to the 3n. This times this would equal x to the 3n. Good, ladies.
Just x to the n.
X to the n, yep. Here's why. If everyone's wondering how we got that, x times n, x to the n times itself. What was the rule the day 1 of exponents? What was the rule? When I multiply, what do you do to your exponents? Anybody remember the rule? When I multiply, what do I do with the exponents? Add them, right? So I have 3n up here. That's where that comes from. And what's your b value? A little bit easier for this. What's your b value? 10. Atticus, what's my b value here?
3.
Oh, you got me there. Yeah. Never mind. I should have said, what was your b cubed? It was 27. You're good. 3. Nice job. All right, plug it in now. Let's plug it in. A, x to the n, plus b, 3, times, what are we plugging in for a squared? A squared, x to the n, all squared. X to the n, all squared. X to the 2n. I multiply when I raise an exponent to another one. Yep. X to the 2n minus. All right, so don't overcomplicate it on me. A times b. X to the n times 3. Just put them together. There's nothing you can do there. Minus 3x to the n. And then finally b squared. Plus 9. Whew. Guys, all right? One more together. 5. 8k to the 6 minus a buck 25. There goes some of your math ability right there. There it goes. Oh, you meant out the window. It was the garbage truck. Picking that up, Jack?
Yeah,
You know what I'm saying?
I guess that'll.
4 squared. Yeah, I get that too. Yeah. Any GCF? No. Everyone see the cubes? 8, k to the 6, and 125. All perfect cubes. All right, so this is difference. So a minus b, a squared, switch the sign, plus ab, plus b squared. Here we go. Identify what a cubed is. What's a cubed? Luke, last one for you. What's my a cubed value?
64. Or wait, it's 8k to the 6.
There you go. Good save. Meaning the a value would be what for this problem? Ones. Anthony, what's my a value then?
2k squared.
Good job. 2k squared. I just take my exponent and divide it by 3 to find what it's equal to. Good, Anthony. And then now, what about my b cubed value? B cubed value. What do we got here? 25. Sabrina, back to you. My b cubed value. Great job. 125. Awesome. Meaning my b value. Quincy, b value, if I got b cubed is 125?
B would be 5.
5. There it is. 5. Just 5. All right, plug it in now. 2k squared minus 5. Well, this is where I do get nervous. 2k squared all squared. 2k squared all squared. 2k squared squared. I think somebody at home knows this. Or here. Zach, redemption time. Cripe.
Is it 4k or 4?
There you go. Plus, what's your AB value? 2k times 5. 13. Sophia, 2k times 5. 2k squared times 5, excuse me.
10k squared?
Good job. And then somebody at the end, b squared. What am I plugging in for b squared? Vinny, b squared.
25.
Yep. You guys feel accomplished? Everyone feel accomplished? Doing some hardcore factoring. And that's it. Don't worry about factoring any further when you do difference of cubes. Questions, comments, any concerns? Okay, you got 11 minutes and 3 problems left. All right, 11 minutes, 3 problems. Answers are up on Classroom, so please check them. Don't be a hero. Even if you think you can go further, just stop. Okay, because there might be a problem here. No, never mind. There's not. I lied. I don't think there's any you can go any further. So you're good. Don't go any further. Don't be a hero. But still look for a GCF first, everybody. Right? Look for a GCF first. Okay, you guys at home, get those 3 problems done. We'll discuss them tomorrow. We'll review, and then it's quiz time. So I'll see you guys tomorrow. Be safe, be smart. You guys in class, keep work trucking. Take care, guys.